Before we start section 5.2, I'd like to give you a little tip for calculating horizontal and vertical distances or lengths of line segments. You'll be doing this in these problems in 5.2. If you have a horizontal line segment, you know that each of the endpoints have the same y-coordinate. So I'm going to call this point x on the left. Let's say the y-coordinate is b. And this, we have a different x-coordinate. It's to the right of x sub l, so I'll call it x sub r, b, and the length of that line segment, regardless where it's drawn, if it's in the fourth quadrant or in the first and second, it makes no difference. You just take x on the right and subtract x on the left, and you get the positive length of that line segment. Similarly, for a vertical line segment, you have the same x-coordinates. We might have a comma y on the top and a comma y on the bottom down here, and the length of that line segment, the positive length, will be y on the top minus y on the bottom. So now we're going to study the area function. Capital A sub f of x will be a function that we determine based on little f, any function, and a point in its domain. So we're given a function little f, and we're given a point in its domain. For any input x, the area function is defined to be, well, the signed area from a to x of f of t dt. This area function is the area, or the signed area, determined by the integral from a to x of f of t dt. So a picture of it, if x were chosen to the right of a here, you can see that it is a sub f of x is this shaded area here. The area would be a sub f of x, where x was chosen right here. So for our first example, let's just calculate the area function at some specific value of x. Here we're given our little f of t is equal to 3. You could call it f of z or use any variable you want there, but in calculating the integral we want to stay away from x because x we're reserving for the independent variable of capital A sub f. So here we have a equals 1 marked, and let's find a sub f of 4. So here's 4, and a sub f of 4 will be equal to the integral from a, which is 1 to 4, a to x of f of t dt, which is 3 dt. So we would have the signed area going from left to right, so it will give the positive contribution of, in this case, the area of that rectangle, which is a 3 by 3. Our answer is 9. Okay, one more example. A sub f of minus 1 would be the integral from a 1 to negative 1 of f of t dt, 3 dt. So here is negative 1, and we are integrating from right to left. So the region that I'm shading here, the rectangle, will be a negative contribution to the signed area. So we have minus the area of that rectangle. It's a 2 by 3, so the answer is minus 6. Hopefully you can see how we can find the area function given a particular value of x. So now let's find the formula for a sub f of x. At first when you do this you say, well, it must depend. The formula will depend on whether or not I pick x here, or maybe if I pick it to the left of 1. But it actually doesn't. I'm going to do it once for you where we pick them in both places, just so that you can see that we end up with exactly the same formula. So let's say we pick x greater than or equal to 1. Then the integral from 1 to x will be the positive contribution of the area of that rectangle. Now, back to our horizontal distance here. Y is 0 here on both points, and so the distance, the positive length of that line segment is x minus 1, and of course it's 3 units in length. So our area will be 3 times the quantity x minus 1. Now, if I pick x over here to the left of 1, I just want to show you once that we do get exactly the same formula. Here we are integrating from right to left, so we are going to get a negative contribution of the area of that rectangle. It's very important that you get these horizontal and vertical distances right because they are positive. Right hand x minus left hand x, 1 minus x is the width, and the length is again 3, and we have a negative contribution. So this will be equal to minus the length times the width, 3 times 1 minus x, which of course is 3 times, multiplying the minus 1 in here, we have exactly the same formula. It doesn't matter where you draw x in order to figure it out. So another example, if g of x is minus x plus 1, or 1 minus x, and a is 0, we're always given a function and a value for a. So a is equal to 0 here, and we know that our function a sub g of x, according to the definition, you should know this definition, the integral from a to x, and now I need to call this a function of t, g of t dt, so it would be 1 minus t dt. Now to find a formula for this, I need to put an x, I need to draw my curve, and that is g of t is equal to 1 minus t, drawn here, x and y intercepts of 1. I need to put my value of a, and now I just pick an x anywhere I want. I could pick it here, I could pick it here, in which case the signed area would give me a positive contribution of this triangle and a negative contribution of this triangle. I'm just going to, now this is not important, I'm going to suppose my x is less than 0. And so I'll put x here. It really makes no difference. You get the same formula as long as you're very careful to get positive distances for the measurements that you need. So we are integrating from 0 to x. We're going from right to left, and so we will get a negative contribution of this trapezoid. Okay, so I'm going to need the length of the two parallel sides. I should label this point here. Let me get another color. That's not good. Label this point. That is the point x, comma, g of x, which is 1 minus x. And this point, of course, is the point 0, comma, 1. All right, so this distance, one base, top y minus bottom y is 0, so it's 1 minus x, and this, of course, is 1. And we're going to need the length, the distance between the two parallel sides, which is right hand x minus left hand x. So we have minus x. Now we can calculate. We're going to get a negative contribution, because we're going left to right, a negative contribution of the area of that trapezoid. 1/2 the sum of the two bases, 1 minus x plus 1, times the distance between the two parallel sides. And if you simplify this, let's see, we have a minus times a minus here, so I'd have 1/2 x, and this is 2 minus x. Multiplying it out, we have x minus 1/2 x squared. You should try on your own picking different values, different places to put your x. Like if you pick your x right here, you'd have another little trapezoid here. Or if you pick your x out here, you'd have this triangle minus that triangle. Do it and see that no matter where you draw the x, as long as you're really careful to get correct vertical distances and horizontal distances that you need, you're going to get exactly the same formula. A sub g of x is x minus 1/2 x squared. So after you have studied this video, I'd like you to do problem 21 on page 320. There's three area functions for you to find. Your f of t will be the same, but you have three different values of a. And then we're going to work on the problems that follow that in class. The quiz will cover the definition of the area function, and you're going to have to compute a formula for an area function given an f of x and an a. So you first draw the little f of t, and you mark your a, that's given. Put x anywhere you want it, and then very carefully calculate the function of x that gives you the signed area.